So in this video, we're going to finish off some questions related to arithmetic and geometric mean. So question 7, it says find the value of n so that this may be the geometric mean between a and b. So the geometric mean, g, between a and b is equal to the square root of a and b. And g is given to be a to the power n plus 1 plus b to the power n plus 1 divided by a to the power n plus b to the power n. So if I square both sides, I get ab should be equal to this whole thing squared. And I'm going to square everything. So I know it looks a bit hectic, but if I square the numerator, I get a to the power n plus 1 squared plus 2a to the power n plus 1 b to the power n plus 1. And this is just using binomial expansion that we did previously in this chapter. And if I square the denominator, I get a to the power n squared plus 2a to the power n b to the power n plus b to the power n squared. Alright, so ab, now I can multiply 2 and the power here. So I get a 2n plus 2 plus 2a to the power n plus 1 b to the power n plus 1 plus b to the power 2n plus 2. And in the denominator, I have a to the power 2n plus 2a to the power n b to the power n plus b to the power 2n. So now if I take the denominator to this side and multiply, I get this expression. Plus b to the power 2n is equal to a to the power 2n plus 2 plus 2a to the power n plus 1 b to the power n plus 1 plus b to the power 2n plus 2. Alright, so if I multiply things out, I get 2a to the power 2n plus 1b. If I multiply the first term, my second term becomes 2a to the power n plus 1 b to the power n plus 1 plus my third term becomes a times b to the power 2n plus 1. So I'm just multiplying it term-wise. And I get a to the power 2n plus 2 plus 2a to the power n plus 1 b to the power n plus 1 plus b to the power 2n plus 2. Now if you think about it, my middle terms are the same. So they are going to cancel out. If I subtract the same from both sides, it's going to cancel out. So I have a to the power 2n plus 1b plus a to ab to the power 2n plus 1. That is going to be a to the power 2n plus 2 plus b to the power 2n plus 2. Alright, so now I want to have the a terms together. So a 2n plus 1b minus a to the power 2n plus 2. And then I'll take this term here. b to the power 2n plus 2 minus a b to the power 2n plus 1. So now we have factor out a to the power 2n plus 1. And I get b minus a to the power 1 here. So if I multiply these two out, I get this expression. And equal to, if I factor out b to the power 2n plus 1, I get b minus a on the right-hand side as well. And these expressions cancel out. So I get a to the power 2n plus 1 is equal to b to the power 2n plus 1. And if I divide by b to the power 2n plus 1 on both sides, I get this expression. And I can actually say a divided by b to the power 2n plus 1 is equal to 1. Now this is only possible if my exponent is 0, right? 2n plus 1 must be equal to 0 because anything raised to 0 is 1. So 2n should equal to negative 1 and n is equal to negative half. So that is the value of n for the annoying expression to be the geometric mean. Alright. So n is negative 1/2. So the p plus qth term and the p minus qth term are given. So we have tp. So let's just imagine we have the pth term. And then we are going tp plus 1, tp plus 2. So pth term, the one term after pth term, the second term after, and we are going all the way until the qth term. And that is given to be a. And then we are going before. So p minus 1, p minus 2, and we are going up until t, p minus qth term. And that is b. So we have b, we have some terms in between, we have our pth term, we have some terms in between, and we have our eighth term. Alright. So let's think about it. Because this is a geometric series, we started b, we are going to br, that is the first term. The second term between b and tp is going to be r squared, and all the way until tp is just going to be br to the power p, right? the first term, second term, and TP is just the pth term after B. So b r to the power p. And we're going to continue this until we get br to the power q, sorry. Because we came back q terms, right? So I have q terms in between. So there are q terms here. So I go br squared, all the way until br to the power q. And I continue this, so if I go to br to the power 2q, I should be getting to my a point. So that is just writing things like this. So because we went back q terms, right? We went back once, twice, we went back q terms. So when we come forward, we need to come forward once, twice, q number of times with r. And then it's the same thing here. We went forward q times. So when we go forward q times again, when you multiply by r to the power q again, we get r to the power br to the power 2q. And that is a. So we know that TP is equal to br to the power q. And a is equal to br to the power 2q. So we want the value of TP. We want to find the pth term. All right. So using this expression, I know that a divided by b is r to the power 2q. Or rather, r to the power q is the same as having this squared. So I square root my left-hand side. Right? So r to the power q is square root a divided by b. And I substitute it here. So the pth term is just b times r to the power q, which is root a divided by root b. Or square root of a divided by b. And when I simplify, I know that b is just square root b squared. So one of these cancels out with one square root in the denominator. So I get square root of b times square root of a. And that just simplifies to square root of a times b. So that is the pth term. That is your value of TP. This is your final answer. All right. Question 9. Given that the arithmetic mean and geometric mean, so arithmetic mean is 17. So let's let our number be a and b. So the arithmetic mean between a and b is just a plus b divided by 2, and that is given to be 17. So I know that a plus b, if I multiply by 2 on both sides, it's just 34. And I know that the geometric mean, so square root of ab, is equal to 8. Or rather, a times b is 64 if I square both sides. So I know these two relationships. From this, I know that a is just 34 minus b. And I can substitute this expression here. So I have 34 minus b times b is equal to 64. So 34b minus b squared is equal to 64. If I take all my expressions to one side, I get b squared minus 34b plus 64 is equal to 0. And now let me use the quadratic equation to solve for b. b is equal to negative 34, negative of negative 34. 34 plus or minus the square root of 34 squared is 1156 minus 4 times 1 times 64. So 256 minus 1156 minus 256, you get 900 here, divided by 2. So b is just 34 plus or minus the square root of 900 is 30 divided by 2. And therefore, b is either it's 32 or it's 1. No, sorry, it's 2. b is 32 or 2. And our a is going to be, if b is 32, then a is 34 minus 32 is 2. If b is 32, a is 2. And if b is 2, then 34 minus 2 is just 32. So our numbers are 2 and 32. So these are our numbers, 2 and 32. So if a is 2, then b has to be 32. If a is 32, then b has to be 2. So those are our two numbers. And finally, we have, this is an interesting question. So this touches on to something we haven't covered yet, but we want to construct a quadratic equation such that the arithmetic mean, so let's just say our roots are alpha and beta. So alpha and beta are the roots. And what do we know about the roots? Well, we know that, hey, if I put alpha or if I put beta into my quadratic equation, then I should be getting 0, right? So I know that, hey, if I substitute x is equal to alpha, I get 0. If I substitute x is equal to beta, I get 0. And let's just say I have a code. So let me just say my the stretching factor is just 1. So I have this equation here. Now, because my roots are alpha and beta, I know that the arithmetic mean, so alpha plus beta divided by 2 is equal to a. And alpha times beta is g squared, right? All square root of alpha beta is g, so g squared is alpha beta. So we are given these facts. So let me expand this quadratic equation. So I get x squared minus beta x, right? X squared minus beta x minus alpha x plus alpha beta is equal to 0. Therefore, x squared minus alpha plus beta x, right? So I just factored out a negative x from my middle term. And when I do that, I get alpha plus beta x plus alpha times beta. And I know alpha times beta is just g squared. And I know that from my first equation, alpha plus beta is 2a. So using those substitutions, I get x squared minus 2ax plus g squared is equal to 0. And minus 2ax plus g squared is equal to 0. So this is the quadratic equation. And that is the answer for question 10. And we are done with this topic.